Okay, back to the number of words you can form with given letters. Now this becomes pretty universal. We'll see how this applies to a lot of different things, but let's just talk about this. I'm going to look at the how many words can I form with the given letters ERIC. Okay, so I'm just going to solve this. Would this be a permutation or a combination? So since I do care about order, I'm going to take all four and I'm going to permute all four of them. Okay, so that would equal 4 times 3 times 2 times 1. Okay, we've done that before with the A, B, C, D. Okay, well, what if I took, I wanted 4-letter words with any letter in the alphabet, but no repeats. So I have to consider that my pool of letters that I'm choosing from is 27. So that would be 27 P, 4 of them. Okay, so 4-letter words with all letters in the alphabet. No repeats on that one. Number 3, there's 4-letter words with any letter in the alphabet. Repeats okay. So let's think about the 4 positions here this time. And we're going to say this time we're going to have 27 choices for the first one. But now it doesn't reduce for the second one because I can choose the same letter twice. And I could choose the 3rd letter twice if I want, and the 4th letter. So I'm going to be multiplying all of these, 27 choices times 27 choices times 27 choices. So this is 27 to the 4th power. Okay, that's going to come into play later. But notice that this one's kind of special because I'm not arranging, I'm just choosing letters. So this is neither a permutation or combination. So that one is special. Let's check out number 4. I have 5-letter words with the letters E, L, L, I, S. I want you to know that these 2 L's, they don't matter where they, if they're switched. Like you wouldn't be able to tell if I switched the 2 L's. So if I just did that, like I did 5P5, I'm going to arrange all 5, it's not going to work. So this is what I'm going to think about doing with this problem. I'm going to think about I have 5 positions, right? Now let's choose 2 positions for the L's. So like say the L's could be here or here. Now I'm going to number these positions 1, 2, 3, 4, and 5. And I'm choosing the positions. So 2 and 4 are my 2 positions. Or I can choose 1 and 4 or 1 and 3 for the L's. But anyway, I don't care what order I choose them in if I'm choosing the 2 positions for the L's. So there's 5 positions to choose from, and I'm going to choose 2 of them for the L's. Now I have to arrange the rest of them because the rest of them are going to go in the rest. So there's actually 3 different positions. In this case, order matters because they're all different. So I'm going to say this would be 3 times 3P3. So I'm just going to permute the next ones. Now, I could do this in a slightly different way over here. You could always do it in other ways. But let's just think about that one. Let's do one with the Mississippi. We did this one before, and we're going to find the number of words you can form with those letters. Let's think about these 11 slots. And I'm going to say let's just place the I's, okay? Okay, let's place the I's. How many ways can do that? There's 11 slots, and I'm going to choose 4 of them for the I's. So that's 11, choose 4. That's how many ways I can place the 4 I's into the 11 slots. Next, I'm going to multiply that times the number of ways to place let's do the S's. So that's placing the I's, and I'm going to place the S's. So there's 4 S's. How many slots are left? Well, I already placed the I's, so there's 11 minus 4, which is 7 slots left. So from those 7 slots, I'm going to place the S's. There's 4 S's. Now I'm going to place the P's. There's 2 P's, but how many slots are left? Well, there were 7. I placed 4, so there's just 3 slots left. So I'm going to say that is 3, and I'm going to place the 2 p's. Then I'm going to place the m. Now, there's only one way to do that, but I could put 1C1, and I got that. So that's the s's, this is the p's, and this is the m. Okay, so I got them all in there, and that's how I would count those. So this is a little different than we did before, but this way might help us think about the problem. I could have done this in a different order. I could have placed the m first, and this number will come out the same. I guarantee you that. But here, let's go ahead and calculate this. If I want to calculate 11C4, I'm going to use my calculator for that. So there's 330 ways. There's 35 ways to do that. 3C2. Now I'm going to take a shortcut here because that's just one less. So how many ways is 3C2? That's just 3 ways. And 1C1, that's just 1 way. So now I just have to multiply those things together. 330 times 35 times 3 times 1 is, did I get that right? Yeah, it's 34,650 for that one. Let's take a look at number 6. 4-letter words with the letters H, H, T, T. Okay, we're using our same method we used up here. Let's go ahead and choose the positions for the H's. So there's 4 positions. I'm going to choose 2 of them for the H's. Now I'm going to choose the 2 for the tails. So there's 2 positions left. I'm going to choose both of them for the tails. The order doesn't matter on the tails. So now I have this. So if I want to calculate this, so 4 choose 2, I'm just going to do this by hand because it's just 4 times 3 divided by 2 times 1 using the formula. It's easier than getting out the calculator sometimes. And 2 choose 2, well, that's just 1. It's only one way to choose both of those. So we reduce this to 2 times 3. So there's 6. Well, 6. I actually have those outcomes listed here. And, you know, we could have just listed the outcomes and done it this way. But what if I had more different letters? So there they all are. There's all 6 outcomes. You can check that out. Okay, well, like this one. If I flip a coin 5 times, what's the number of outcomes with exactly 3 heads? So if I have 3 heads and 2 tails, then that's the outcome I want, or one of them, and then I have to like arrange them. So it's the same as the word problem. How many ways, how many outcomes in those flippings would have this? So I could have another outcome would possibly be tails, heads, 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 tails, like that particular outcome. Well, I want to count these, and the order of the heads doesn't matter, and the order of the tails doesn't matter, but the general order does matter. So I'm going to treat it like I'm just rearranging these letters into words. So let's place the heads first. Well, there's 5 different places I could place the heads, and I'm going to choose 3 of them for the heads. Now, there's 2 places I can choose for the tails, and I'm going to choose 2 of them for the tails. Now, this is just going to end up to be 1 because once I place the heads, pretty much the tails are already defined. Like I can say, there's my 5 slots. I'll choose heads there, and heads there. Now I don't even have to choose for the tails. There's just going to be one way to place that. So that's why that's 1. So that's how we would calculate this answer. We are going to take this one step further and answer the question, flip a coin 10 times. What's the number of outcomes with these 4 things? How many outcomes are there? There's no heads. Well, if I did that like I did it before, there's 10 positions for the no heads, and I'm going to choose 0 of them. There's still one way to do it. Now, that is all tails. So that corresponds with all tails, and that's kind of why 10 choose 0 is 1. There's one way to do that. Now, if I want to choose 1 head, there's 10 different positions for the heads, and I'm going to choose 1 of them. And remember, that's my shortcut, 10 choose 1. There's just going to be 10 ways to do that. All right, try these next 2. All right, so the next one is 10, choose 2. And I'm going to go ahead and do this. This is 10 times 9 divided by 2 times 1, which is 45. And the next one is 10, choose 3, and that equals 10 times 9 times 8 divided by 3 times 2 times 1. So a little bit of cross canceling here. This isn't too bad. That's a 4, and that's a 3. 10 times 3 is 30, times 4 is 120 ways outcomes for that.